So we've heard a number of interesting talks in this session. We started with the patient perspective from Kalnan Sorensen and Father Matthew from Seattle. This was a very mature and articulate young lady of 11 years of age. She was actually the first participant in the STAR clinical trial, which was the trial for the Adalurin therapy that took place in North America. So this was important because we got the perspective of the patient who was actually quite young when first enrolled in the study, so she wasn't really aware of what it was all about, but it is now. But both her and her father are very thankful to take part in this trial. Unfortunately, the results weren't as everybody had hoped for. However, I think it's important to keep in mind that a lot of important information and experience were gained from the trial, and I think this will guide future trials as well, so that we can improve upon the results that were gained there and the experiences. In that trial, it was an oral drug, so it was a powder that was dissolved, in her case, in applesauce. And here we can also see so that there could be some lessons for optimization of drugs, drug delivery in future trials, especially for the pediatric population. Um, they have experienced, so Kalnan has experienced subjectively improved nystagmus as well as better depth perception. However, it's hard to say whether this was due to the drug or if it was due to other factors or even just normal development. And also, as they mentioned, there were too few participants in the trial to group the participants in order to really investigate the improvement, that question. Also important that, and this has also been discussed, is touched on a little bit, and we can discuss this later, that a topical formulation could possibly be important, as well as the optimal timing of treatment and endpoints for clinical studies. Then we went on to the talk of Cheryl Gregory Evans, which was focused on potential new therapy for aniridia in the anterior segment. And Cheryl talked about glaucoma, which is a very highly prevalent but serious problem in aniridia that can, of course, lead to vision loss. The problem with glaucoma and aniridia is that the aqueous humor fluid, so in the anterior chamber, the outflow or drainage of this fluid is blocked. And this is due to misdevelopment or underdevelopment in the drainage structures in the eye. And this leads to increased intraocular pressure. What Cheryl described was a novel approach by looking at a downstream target of PAX6, because PAX6 itself, as a transcription factor and protein, is difficult to regulate, and it's very the dosage of PAX6 is very sensitive, so it's very hard to get the right exact dosage of PAX6 correct. So by looking instead at the downstream target, which is TGF beta 2, this is important for proper development of the lens and the drainage structures of the anterior chamber. Cheryl described a small eye mouse model where they looked at using engineered mesenchymal stem cells to express higher levels of this factor TGF beta 2 in the eye. And they tested this by injecting this into the anterior chamber and looked at it after 10 days in the mice, and found that this therapy was as good as Adalurin in terms of resulting in more developed structures such as the trabecular meshwork and the Schlemm's canal for the drainage fluid. So this is a very potential, very exciting potential future therapy, and it could be given postnatally as well, and irrespective of the particular mutation in PAX6. Then we went on to my talk about aniridia-associated keratopathy, and I described how this could progressively lead to the loss of corneal transparency over many years. It's highly variable, however, and genetics can play a large role here. So it's important to know the type and location of the PAX6 mutation because this can affect the prognosis. Also important to realize that the limbal stem cell niche does not fully mature until postnatally, and it's still not known whether the limbal stem cells are absent or if they're dormant or non-functional in aniridia. So this could have therapeutic implications. There could be a potential window there for rescuing the limbal stem cell function. Also, it's important to realize that aniridia-associated keratopathy is more than just limbal stem cell deficiency. It's also characterized by an inflammation of the ocular surface, a nerve deficit, a dry eye, and meibomian gland dysfunction, for example. And then we had an interesting talk by Ali Jalilian from Chicago, who described his work in enhancing PAX6 expression through novel drugs or compounds. And again, this does also not depend on the type of mutation, so it could be applicable across the spectrum of PAX6 mutations. Here he talked about a drug screening that revealed that one class of drugs called MEK inhibitors could potentially induce overexpression of PAX6, enhancing it by 2 to 2.5 times in vitro. So they tested this MEK inhibitor, and MEK inhibitors are drugs that are in clinical trials for melanoma. So it's a possible to have a quicker approval process for other diseases such as aniridia. So they tested this in the PAX6 mouse model, giving the mice either topical or oral MEK inhibitor for about 4 weeks postnatally. And this appeared to improve the phenotype of the cornea. So the cornea was not as thick, but the epithelium became thicker, resembling more of a normal cornea, and there was less scarring in the cornea. So this is interesting, but there are potential safety issues when delivered systemically. Potentially in the retina, it could increase fluid buildup in the retina. And however, here also the topical formulation could be an interesting approach for the future. Finally, we heard from Julie Daniels on future perspectives on limbal stem cells. So it's known that there are generally poor outcomes with limbal stem cell transplantation from donor corneas onto the ocular surface of aniridia. And this is not only due to the poor corneal condition in aniridia, but also due to potential immune incompatibility of the cells. Here, the idea that Julie presented was that one should not only strive to provide limbal stem cells, but also a niche-like structure to ensure their continued health and survival after transplantation. And she talked about doing this perhaps through engineering a tissue matrix made of collagen, where they seed not only the limbal stem cells on top, but supportive cells such as the stromal keratocytes. And this promising technology has now received regulatory approval, and they're going to start with the first trial in humans on this summer. So that's just a short summary. Thank you.